Before we start going through the case studies to show off the various RxJava operators in detail, I want to take one more quick detour to talk about something called the AsyncTaskBarrier framework. And you'll quickly understand why we do this first, because all of the case studies use this particular framework to be able to run the asynchronous computations effectively and correctly. So there's implementations of this programming API for both Project Reactor and RxJava. Since we're just focusing on RxJava in this class, we're going to focus on the AsyncTaskBarrier framework for RxJava. But if you're curious, you can also go and look in my GitHub repository and find the same sort of thing for Project Reactor, which is similar but not identical to RxJava. So when we start getting into the case study section of the course in a moment for RxJava, you'll see that we generally have a bunch of tests that are going to run asynchronously. So we deliberately want them to run in the background. And that raises the question, how do we wait for those things to finish conveniently and efficiently? And in particular, when we invoke the test methods, they're going to run in the background, and the methods will return right away. They basically come back with what is effectively a completable future, although it'll be called a single or an observable or a flowable or whatnot. And so you make a call, and the call doesn't block. It just returns you something. It's essentially a proxy to the computation's results when they finish running asynchronously. So that leads to a certain set of challenges. And just let me quickly clarify what the heck I'm talking about. So here's an example. This is an example from Project Reactor, but the same thing applies with RxJava. You have this call called subscribe on, and it says run this computation in a background thread. And so this computation will return before the background thread may have finished its processing. So this causes us some consternation. So what we are going to do is we want to define one single location in all of our driver programs where we can wait for all the asynchronously executing test methods to complete. So as you can see here, and you can find this code in this example, here's the main program. And we go ahead and we register a bunch of test methods that will run asynchronously. So all these methods like test fraction reduction async and test fraction multiplication callable 1, blah, blah, blah. These are all registered with the AsyncTaskBarrier. And we normally do this for things that will run asynchronously. It'll work for synchronous stuff too, but it's really intended for things that run asynchronously. And then what happens is we say, hey, AsyncTaskBarrier, start running all of these tasks asynchronously. So we register them all first, then we go ahead and we run them all in the background. And we're then going to have a single place in our program that will block, waiting for all the other computations to finish. And the reason for doing this, the reason we have to do this is because if we don't block that main method in the program, then the program will fall off the end of main, and the process will exit, and all of our asynchronous computations will be lost. So we need to have one place where we wait for everything to finish. But we only want to have one place because we don't want to, if you remember all of our discussions we had about completable futures, we don't want to be blocking things. We want to be joining. In completable futures, it was join or get. With RxJava, there's a method called blocking get. We don't want to be blocking stuff unless we absolutely have to. And here's an example where we absolutely have to, because if we don't block, we're going to fall off the end of main. So we have a framework that will asynchronously or synchronously run tasks and then ensure that the calling method doesn't exit until all the asynchronous processing has completed. And, whoops, that was weird. We're going to take a look at the implementation of these methods after we cover RxJava's operators in detail, because it would kind of get ahead of ourselves if we went and looked at those things now, because we haven't really explained how everything works. So we will look at this later, but I wanted you to be aware that there was this framework where you can have a single point to wait for a bunch of asynchronous computations to finish.